Alright, I want you to skip 7 and 8 just for now. We will come back. I want to use this graph underneath 7 and 8. It's 4, 9, and 10, but I also want to use it for 7 and 8. So did y'all get all these questions? Yes.
Why is on number 6, why does it say 4?
Because the diameter is 4, so the radius is 2, and 2 squared is 4. Alright, we're skipping 7 and 8. Now we're looking at a graph on 9. Two things we need to plug it in the formula. We need HK, which is your center, and we also need the radius. Can we find those two things by looking at the circle? Yes. So your HK is just the center. So H is -2, K is -1, and then your radius is half of the middle of the circle. So 2 boxes, which means your radius is 2. So if you take that and you plug it in your equation. Try 10 when you're done. Check your answer. Good? Okay. Now let's go back to 7 and 8. I wanted you to be able to read this circle before we drew all over it. So, do you remember the story about the girl with really long hair with her hair swept to the side? Yeah. The what formula? Distance. Technically, and the book will tell you, in order to do 7 and 8, you have to use the distance formula. Raise your hand if you don't like using the distance formula. Good. I have a way around it. So, this is a center, 3, -4. It passes through -1, -4. Well, can't we just plot those points? We have the center. If we know the center and we know another point, can't we find the radius? So let's do that. So this is, I want you to use this graph, which is why we skipped it to answer 9 first. So now, 9 is not intended to be used for 7. So it might look weird, but try it.
Can you give us the distance formula?
Yes. You try that. You try to plot those two and find the radius. Girl with long hair, sweep to the side. She has 2 eyes and a nose, that's a plus sign. Her eyelashes are so long they're squared. X pupils are minus. X comes before Y. Do you want the distance formula? There it is. If you don't, here's how I plan to do it. Over 3 down 4, over 1 down 4. So what we've just plotted, we plotted the center and the side. So what's the radius? 4. Because the other side would be 4 the other way. So you have to know what you're looking at when you plot those. This is the center. This is just another point on the circle. So the radius is 4, and now that I know that, I don't need this anymore, and I can write the equation. Okay, let's try the same thing for 8. We know the center, we know a side that it passes through. So let's plot those. Here's the problem. I can't count how many boxes that just went through diagonally to find the radius. You might could, but we're human, so we're going to make mistakes, and it could not come out to be exactly correct. But what I can do is, if I draw a line right here and a line right here, Doesn't that make a 90-degree triangle? Yes. What's the height? 3. What's the base? Can't I use Pythagorean theorem to find that radius? Wouldn't you rather use Pythagorean theorem than the distance formula? Leave it as a radical. Trust me. Leave it as a radical. You will see why. So once you solve this, you have 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4, so those added together are 13. Leave it as r squared. Because, isn't the formula equal to r squared? Isn't this formula equal to r squared? So don't you just want what r squared is equal to, which is 13? So you could take the square root, but then you're just going to undo the square root to get it back in. Does that make sense? Okay, so leave it as that, and then use your center. So x squared plus y minus 3 squared. So if right here, if I would have plugged in the square root of 13, I would have had to square it, and they just would have canceled each other out. So it's equal to 13. That's your answer. All right, now we're going to go the opposite direction. We're given the equation, and we need to graph the circle. The only tricky part about this, obviously the center is where? 0, 0. But remember when we plugged in the radius, we had to do what to it? We had to square it. So when we're finding the radius that's already in an equation, we have to take the square root. Because we squared it before. Now to undo it, we need to take the square root. Because this is r squared. So to unglue that, your radius is just 4. So I plot your center point at 0, 0. Now I want you to go in 4 directions, the only perfect ones. We're not going to guess and go at a 45-degree angle. I want you to go 0, 90, 180, 270. So go over 4, up 4, side 4, and down 4. As long as your points are correct, I'm not going to judge how crooked your circle may be. My circles tend to look like a force field or something. They never look like a circle. See, it's just terrible. As long as your points are perfect, I will not judge you for your crooked circle. Try 2, 3, 4. All right, if you're done, Go ahead and plot the points on number 5. So the problem in number 5 and 6 is that they have given us 3 points. We don't know which one's which. But we're going to use context clues to figure it out. So I plotted the 3 points. -2 up 2, -1. Oh, I did an extra one. -1 up 3. Okay, so technically this middle one isn't here yet. Is that right? Is that the first 3? Okay. So we need to use context clues to know that all 3 of these are equal distance around that one that I put and then whited out, didn't I? So that's probably going to be the center. And then I can draw another one right here, and that is my circle. So you just got to look around and see what they're equal distance from. So it wants us to write an equation. So now we know that our center is -1, 2, and the radius is 1. Okay, so now number 6, I plotted these points. Well, at first to me it looks like this could be the center, and then I could draw 2 points here and 2 here, but then that makes a square. So that can't be the center. But then I realized that this is 2 away from this, 2 away, 2 away, so here's my radius. Or not my radius, but my center. And the other one's right here. Congratulations, you're done learning. Now we just have to remember it all to take our exam. Don't forget that we learned about rectangles, square roots, parallelograms. Is that on this one or is that on one? I think it's on this one for sure for standard geometry. I don't remember.